Okay, here I want to discuss the segment and circle quiz. The rules that are being used here, rule number 5 has a diameter that forms a right angle with a chord. It's perpendicular to a chord. We'll cut that chord in half and we'll cut the arc determined by that chord in half. So those are congruent segments now and those are congruent arcs. Okay. In this one, and it actually works if you know any of these three things. If you know the chords are congruent, you know the arcs will be congruent, and they'll be the same distance from the center. Or if you know the arcs are congruent, it gives you the other two. Or if you know that two chords are the same distance from the center, it gives you the top two. So any one of those three conditions gives you all three of them. So, and what it's saying is, suppose these two chords are congruent, and I've got them marked congruent by showing their halves are equal. Why would those be divided into halves? Because these are diameters here, or parts of diameters, by that rule up top, that are perpendicular to chords, so they cut them into equal parts. So if the two chords are congruent, they will be the same distance from the center. Distance is always measured from a point to a line by taking the segment that is perpendicular to the line. So these two segments are congruent, and also the arcs out here are going to be congruent. The next one deals with two tangents. Well, tangents in general, but if you have two tangents that come from the same point outside the circle, then those two tangents will be congruent. Remember, a tangent is a line that intersects a circle at a single point. Also, the second rule that we've got over here is that tangent segments will be perpendicular to the radius drawn to this point out here, which is called the point of tangency. That lets us put the right angle in there and there. Okay, our last two rules deal with segment lengths, and it says that if two chords cross inside of a circle, then they get divided into pieces. This chord here gets divided into A and B, that chord there into C and D. The rule says the product of the pieces of one chord, A times B, equals the product of the pieces of the other chord, C times D. The proof of this fact is based upon similar triangles. And in our last picture, we have an angle whose vertex is on the outside, so it's being formed by, in this case, two secant segments. A secant is a line that intersects a circle in 2 points. But the rule that we're about to express, which is the part outside times the whole length, equals the part outside times the whole length. I know that's hard to see here, but you have it on your rule sheet. Works whether you have two secants like here, or a secant and a tangent, or even two tangents. And what the rule says in words is that the part outside multiplied by the whole length, which up here is A times B, equals the part outside times the whole length, which down here is C times D. So every one of our problems in the quiz is going to be one of these. I think maybe one problem might use one of our earlier rules. Okay, so here's the quiz. In this circle up top, we have two tangent segments coming from the point C. We're given that guy's 12. We're also given this radius here, AP is 5. Okay, well the first thing it asks is how long is PB? PB is also a radius of that circle. All radii are congruent, so if that radius is 5, that one is 5. We have 5. I went ahead also and marked that PD is 5 because it's a radius also. The next thing the quiz wants to know about is what's the length of segment BC. Well, BC, this is the rule that says if you go from C over to A, that's 12. Your other tangent segment from C over to B is also going to be 12. Two tangent segments from the same external point are congruent, so that's your 12. In order to get the length of PC, you're going to have to use the Pythagorean theorem. So here I've taken this right triangle. Oh, we haven't established it's a right triangle yet. It's a right triangle because this angle at A and also this one at B are right angles by one of our rules on the other page. Let's see, by rule number 7 here. Says the tangents form right angles with the radius. Okay, so that gives us the 90-degree angle there and there. That sets up the Pythagorean theorem. So here's triangle PAC, and I've drawn it right over here again. it would say, the Pythagorean theorem would say 5 squared plus 12 squared equals x squared. And when you solve that, you'll get x being 16. The square root of 169 is 16. So PC is 13. Now, once you have all of PC, that whole deal is 13, then DC is going to be 13 minus 5 is going to be 8. And that's your answer here. 13 minus 5 is 8 for DC. And we've already answered that part, so we're done with that diagram, except what's the diameter of the circle? Well, if the radius was 5, the diameter would be twice that, and 2 times 5 is 10. Okay, so a lot of given information on the problem at the bottom of the page here. We point out one thing, and then we'll note it again in just a second. In period 6, we changed the measure of arc SR to 40. In earlier periods, that was 80, so I'll discuss the answer both ways. Okay, what we have here, because we have in the given that SP is 16 and MO is 16, we've set up the situation where you have two chords of the same length, both 16. Well, that means the arcs they determine, SP and MO, are going to be the same measure. All right. Also, they will be the same distance. KN and KQ would have to be the same length because the two chords would be the same distance from the center. So, since the given information gave us that KQ is 6, I've also got a 6 on KN now. Also, we know both of these arcs were 16, and we know we've got these segments coming from the center of the circle here are perpendicular to those chords, so they bisect the chords. The 16s are divided into pieces of 8 each. Okay, so we've answered some things. The length of MN over here is 16 divided by 2 was 8. KN was the same as KQ, it was 6. Now, to get KL, notice what KL is in this picture. KL is a radius. Okay, in some classes, I think also we just left that. It used to be T and we changed this to KT, but it's the same thing. We're looking for a radius. What you want to do when you have a radius that you don't seem to have a way to get is ask yourself, do you have a way to get any radius in that picture? And there are several. I could draw a segment from K over to M, and that would also be a radius. And look what I've got here. I've got the Pythagorean theorem going again. And actually, I've drawn that triangle down below here. I'd have 6 squared plus 8 squared equals y squared, where y was the length of that km. I could solve that, and I will have y equals 10, and that's the length of this segment. Any radius I ask for, whether I call this KL or KT or whatever we've called it in a very different classes, we're still going to get 10 for our answer here. Okay. Now, here's the problem that will vary depending on which class you are in, asking for the measure of arc MO. If you were in period 6, or you took the period 6 version of the quiz because you took it some other time when the measure of arc SR was 40, then what we have here is that because this diameter bisects the arc as well, that the 40 that is there has to also be a 40 here, which makes our big arc 80. Okay, and if that arc is 80, so is the one on the other side. It's 80. So the answer was MO was 80. Now, if you were in one of the classes that had the measure of SR given to you, instead of being 40, it was given to you at 80, then what would happen is that we'd mark that out. That would be 80. We'd mark that out. That would be 80. Okay, that made our big arc here 160, and therefore the other big arc on the other side would have been 160. So this answer is 160 if you took an older version of the quiz. If you took the newer version, the what I call the period 6 version, your answer was 80. Okay, on the back of our quiz then, we've got a circle P given, and we are given that this is 5, this is 6, this is 7 here, and we're trying to find that guy. So I put an X on him. And what I have then, these are two chords crossing in the circle. I'm going to use the rule. that the product of the parts of this chord, 7 times x, equals the product of the parts of that chord, 5 times 6. And I've got that work shown right here. And you get 7x is equal to 6 times 5, which is 30. And then x is going to be 30 divided by 7, which perfectly good answer. Just leave it like that. So 30 over 7 is our answer. The next problem asks us about line CD. Now here's a key. It's a line. We have two special types of lines in this chapter, secant lines and tangent lines. Secant lines intersect circles in 2 points, tangents only 1. We can see that line CD, if it was extended there, you'd have line CD. Then line CD is a secant line because it intersects the circle in 2 points. So your answer there is secant line. Okay, on problem 11 part C, you're given the length of CE this time. I'm going to scribble out this other stuff. CE is x. Okay. DE is x plus 3. AE is x. Let me scoot that down so you see where I put that in. AE is x plus 16/3. So that guy right there, x plus 16/3. And the last piece is that BE this time is 3. Well, I'm going to do this problem the same way I just did the one where we had 7x equals 6 times 5. I'm going to multiply the pieces of this chord, x times x plus 3, and set them equal to the product of the parts of the other chord, x plus 16/3 and 3. Looks like it's going to be a nasty problem, but it's really not. Here's the work to it. So there's the setup that I talked about. On the left side, when you distribute, x times x is x squared, x times 3 is 3x. Over here, nice things happen. 3 times x is 3x. 3 times 16/3, the 3's cancel, you're left with just 16. More good things are going to happen on the next step, because I can subtract 3x from both sides, and it's gone. X squared is 16, and you're done. Take the square root, x is 4. It really plus or minus 4, but minus doesn't work in this problem because it gives us negative segment lengths. So just plain old 4. Lastly, this is a problem on 11 part, so you had 4 there. On 11 part C, this is actually an angle problem. So it goes back to the previous quiz. This is a 40-degree angle. That's a 60-degree arc. And if I put a variable, I know I've used x a million times. Let's call this y. Then we're trying to find that y. Well, the rule again for angles is when the vertex is on the inside of the circle, the angle is the arcs added divided by 2. So my work down here is that the angle, 40, equals the arcs added, 60 plus x over 2. And if you solve that, you're going to get x being 20. Okay, our last diagram then deals with and this was just an extra line I said to ignore, deals with secants that intersect outside the circle, or even a secant and a tangent. And when the intersection is on the outside, that's our final rule from our rules diagram. It's this one here, that the part outside times the whole length equals the part outside times the whole length. Okay. So, the given information is that this guy is 3, BC is 7. Now, we don't have a rule that talks about the inside, but sometimes we have to use the part inside the circle, that chord, to figure out the whole length up here. So 3 plus 7 gives me 10 as the whole length of segment AC. All right. Now, to find the length of A, and let's just say that that 10, by the way, is the answer to AC. That's one of our answers there. It's 10. Okay, to find the length of AE, notice what AE is. It's the, when we talk about outside and whole length, for the segment that contains the points A, D, and E, AD is the part outside. AD is the part outside. AE would be our whole length. So we're after a whole length. So if I call that whole length, I think I've called it in my work, I've called that whole length there X. Then what we have is that part outside, 3, times whole length, 10, equals part outside, 2, times whole length X. And now I've got that work here. 3 times 10 equals 2x. And we're going to get 30 equals 2x. X is 15. And that's our answer for AE. To find our answer for segment AF, well, notice what segment AF is. It's this tangent segment here. And we've seen in class, let's call its length y. Then we've seen in class that what we do when we've got one of these guys being a tangent, all you have is a part outside. So we use that y as both the part outside and the whole length. Okay, so now what you've got is that part outside, 3, times the whole length of up there, 10, equals part outside, y, times whole length, which also we use y in that case. So what you get is that 30 equals y squared, and you can see our answer there. AF, which is our y, is the square root of 30. And that takes care of this quiz.